Hello, I'm Roger Bisbee and I want to talk to you about Worcester's green floor underfloor heating. It's part of an ongoing commitment from Worcester to bring you total heating and hot water solutions. And we're going to be installing green floor in this house. So let's go and have a look and see where we'll be working. Underfloor heating is growing in popularity, and for good reason. It goes hand in glove with today's high efficiency boilers and heat pumps. It gets the very best out of the system. Well, Worcester is already a leading brand in boiler manufacturing as well as in solar thermal hot water systems and heat pumps. And their green floor underfloor heating system further enhances this to give you a total heating package. This gives you the reassurance of a leading brand and gives your customers the same peace of mind. But what do you, the installer, get in the way of practical benefits when it comes to laying the system? Well, the pre-insulated pipe positioning panels are very easy to use. You don't have to mess around with clips, and you can actually lay the pipe on your own. Okay, so that's the holes drilled for the pipes to go through to the manifold. We've got 6 holes, 6 pipes, because we've got 3 circuits here. The reason we have 3 circuits, even though it's one room, is because the pipe length must be limited to 120 metres maximum. So before we can put the pipe in, we need to put down the pipe positioning panel, which goes on the floor here. It's got some insulation underneath it, and on top of that we put the edge insulation, which is also an isolation. Now the reason I call it an isolation is because it doesn't only insulate the screed from going up, transferring the heat into the wall, it also isolates it so that we get a bit of expansion. You'll notice that this is nice and soft, and that will allow the screed, as it warms up, to expand slightly. Now we're really racing along. We've got all the edge insulation around, and we've already started putting the panels down. Some people worry about walking on these panels, but so long as you're sensible, they're perfectly tough, easy to walk on, and even when you've got the pipe down, you shouldn't do any damage to the pipe just by simply walking over them. I'll just show you how these go together. They interlock, and there's an overlap so that you can make sure the panels are nice and snug. There's no chance of the screed, even if it's a liquid screed, there's no chance of it leaking down in there. So I better get on. We've got a bit of work to do, and I've got a little bit of help, and we'll carry on putting this down. Well, we've managed to put down these 2 circuits very quickly indeed. It took us about 15 minutes per circuit to do these, so we just got 1 to go. But I just want to show you what we've done here. We used the drawing that Worcester have supplied to lay the first 2 circuits following the pattern. Now the pattern is a Snell pattern, which means that it just runs into the middle, that's on the flow, and then runs back out the same way. So each one of those is mapped out. You can see that it misses the area where the fireplace is. When you come to cutting the pipe, you have to make sure that the length you've got left is enough to do the circuit. And you might wonder how you do this. You wouldn't want to get right to the end and find you were 4 meters short, because the key thing is not to put joints in the floor if we can possibly help it. So the way this is done is that we take the drawing, and on the drawing it gives each circuit, and it gives the length of pipe required for each circuit. On the pipe it's printed. This is a 200 meter coil, so we've started using it from the 200 meter, which is the outside edge. We now find that if we look on the printed edge, it's got 121 meters left. So if we had another circuit to do, we could calculate that this coil was enough to do it. So I cut myself off a nice margin to get through the wall and up to the manifold. Simple job. And lay that coil aside for my next job. Okay, that's all the pipe laid now. Let's now go and look at what we're doing at the manifold end. So here we are in the room adjacent to the room where the underfloor heating's going, and you can see there's flexible pipes coming up through the floor there. And here we've got the existing central heating system used to supply the radiators. That's now been capped off, that flow and return, and we've teed in a new flow and return to go to the underfloor heating pump. This is done in 22mm. We've got a zone valve because the rest of the system is still operating on radiators and we want separate control of that. So we brought the flow and return round ready to connect up to the pump and the mixing valve, and then that will go onto the manifold. Okay, so that's all the pipework connected up now, and we're ready to flush it through, get rid of any debris. Hopefully there won't be any debris, but we get rid of the air out of the system, and once we've done that we can put it under a pressure test. But I'll just show you what's going on here, because for some people it's a little bit daunting if you've never done any underfloor heating before. But it's very simple. What we've got here is the flow from the boiler. It's coming up into the thermostatic mixing valve. Now we set this anywhere between 30 and 50 depending on what we want. And that mixes a little bit of water, lets us go through the required temperature through into the underfloor circuits. Here are the flow regulators, and then it returns, but if it's coming through hot, it's going back through the system, it's recirculating. Now as the temperature drops, it's sensed by the mixing valve, and the mixing valve just bleeds a little bit of hot water through there just to warm it up, so you get the maximum efficiency out of it, and that way you do control the temperatures. If anything went wrong, that mixing valve failed, or there was a failure on the boiler thermostat and the water was coming through too hot, then you've also got a limit stat here which will shut the pump off if the water is coming through too hot for the circuit. So it should never be a case where we're getting water coming into the screed which would potentially crack the screed. That just shouldn't happen on a good system. We've got a couple of isolating valves here. We turn those isolating valves off when we start because we're going to fill from our manifold with a hose and just use mains pressure just to get the system going, and we fill each circuit individually. So we make sure that we've got all the air out of one circuit before we go on to the next one, and then we fill up all 3 circuits like that. Now we've got the system filled up and we've flushed it through and got all the air out of the system, we're ready to put it under pressure test. And for this we use a standard screw-on pressure gauge, which we're going to leave on the system for 48 hours just to make sure it's absolutely fine, and of course while the screeding is going on. And then we need to open all the circuits up, so we can just make sure they're open on the top here, but also on the bottom here. We turn those round and make sure that they are also open. When we've finished and we adjust the flow rates, we can lock those in position, but for now we're going to have them fully open. So all I've got to do now is pump a little bit of pressure in. We're going to put it up to 6 bar and see how it holds up. Now the drying time is a crucial thing. What we're talking about is a setting time on the screed of 21 days. During that time, the more moisture you can keep in the screed, the better. So if you can cover it with something like a bit of polythene and it sweats away underneath there, that will improve the curing time and you really will get a first-class screed. After that time, it's the drying time. Now a general rule of thumb is that you allow 1 millimetre per day for drying. Now the screeders are well underway, they've already done half the room, and even though they've been very, very careful with that pipe, I still want to just come back and check the pressure's holding up. And I noticed that the pressure's crept up. Actually, when I pressure tested it, I put it up to 6 bar, and then I dropped it down to 4 to hold it at 4, and now it's crept up again to 5. The reason that's happened is because the screed is already beginning to cure, and sand and cement, that creates heat, and as it's curing, it's expanding the water in the circuits, and that's creating our extra bit of pressure. So that's the reason I dropped it down a bit. It can now creep up to 6, even 10 bar if it likes. So this is the screed all laid, and as a plumber you might not have too much influence over what goes on the build, but if you can possibly manage it, persuade everybody to stay off it for at least 3 or 4 days, because during that stage any pressure on the screed starts to flex it, can cause cracking. And under those circumstances the ideal condition is to keep as much moisture in the screed as possible and keep it slightly warm. The one thing you don't want to happen is any freezing. So now that's the end of a 3-week curing process, and what we now want to do is commission the system, get it up and running so that we can run a bit of heat through that screed to help dry it off. So we've got the system switched on, ready to go. I'm using a RF thermostat here so I can just dial in the heat and bring the controller into action. And then what I need to do is to check the pump is up and running, and then adjust it so that we get the flow rate right through each of these circuits. Now down here on the flow controls, if I look at the drawing, it tells me that I need 2 litres a minute going through each circuit. That'll vary according to what circuit you've got, but it will be on the drawing. So I just make those small adjustments there, make sure that's going. Now the temperature, I want to check the temperature on here, and what I'm going to do is run it at 25 degrees centigrade for 3 days. After that I'm going to increase it to 40 degrees centigrade to continue the drying out process in the screed. I do that so that we gently introduce the heat into the screed so we don't crack it, and we begin that drying out process. And because we're drying out, what I want to do is leave the heat source running day and night so that we've got 24 hours of continuous heat. We don't want to be switching it on and off during this period, so we just run that nice and gently so that it dries it out. And then when it comes to laying the floor covering itself, whether it's wood or tiles or whatever it is, even carpet, then you need to turn the heating of the screed off so the underfloor heating isn't on anymore. The screed can cool down enough, and then the floor layer can do their bit, and then after that it can be used in the normal way. Well, this has certainly changed a lot since I was here last. It's always nice to see a finished job. I say see, actually with underfloor heating you can't see very much at all, but you know immediately when you go into a room you can feel that lovely low level of even heat. Right from the initial stage we got that Worcester drawing. It was designed to work with this particular building with the heat losses to achieve this level of comfort with the Worcester ground source heat pump. And of course the other thing that's important is floor coverings. You specify the floor coverings at the beginning, and that gives you the heat outputs. It can be used with wood floors, with carpets, or with ceramic tiles, which is always a favourite. And one of the things that I find with underfloor heating is the jobs sell themselves. Once you've installed a green floor system and their friends and family have come around and they've experienced the increased comfort levels, not to mention the reduced running costs that come with underfloor heating, then you find yourself getting a lot of referrals. So get involved, contact Worcester, get more information and book yourself on a training course, and you could find yourself very busy indeed.